Oh, g'day, Mr. Bennett here. Just want to give you some help with the investigation in terms of using Geogebra. The idea of using Geogebra is it allows you to investigate things really quickly. All right, so if I want to explore the polynomial, which is obviously a cubic, I've got values here like I'll make c equal to 0 as well. Okay, so you can see there, and if I make d equal to 0 as well. So if we start from a starting point there, what we can do is we can play around with our a value, and let's make k equal to 1 as well. Okay, so if that's the case, that's my a equals negative 1, negative 2, negative 3. What's it doing to my graph? Okay, if I make a equal to 0, if I make a equal to 1, 2, 3, 4, 5, got the idea? So you can actually see the pattern of what's actually happening with the a value. What does it do? Let's make the a back to 1. Right, let's say looking at our d value. What does our d value do in our equation? So if I drag that across, okay, so making d positive obviously translates the graph, doesn't it? So you can see what's actually happening. You can print some screens and you can show what's actually happening with that. Alright, it's really important. What happens when k is equal to 1, 2, 3, 4, 5 up there? What happens if k becomes a negative value? Got the idea? Alright, so that's really important to look at that. Alright, and then we can start introducing things like b. Okay, so what happens if b gets positive? Okay, what happens if b becomes negative? What's that doing to my curve? Oh, you can just play around with that. Okay, you can talk about some examples. What happens if my c value, okay, is negative? What happens if my c value is positive? There. It's probably harder to relate the b and the c, but certainly the a and the d should be easy to actually talk about, because if I just add d, and what's happening to my graph, you can see what's actually happening to the graph there, can't you? Alright? So the part of the thing is that you need to relate some of these terms in your discussion. Now, if you look at the first three of the functions, I think you should find that they are very similar to each other, and you can talk about those in general. And then the second three of the functions are, in fact, you should be able to see a relationship between those. All right. Now, obviously, Geogebra helps you to explore that relationship. Now, really important when you're doing this thing here is you can change things on the Geogebra. So you can change the properties. So you can actually make these different colours if you want. I can make that there. Alright, and then obviously what you can do is print screen. Okay, so you can print screen that, and then you can go into a Word document and you can paste that in there, which is really useful. Right, so it just means that you could have a whole heap of these particular curves set up. So I could crop that. So cropping means just getting to the bit that I really want. Okay, so I might just focus on that bit there, and then I can make that whatever size I need. Okay, so I can actually make that, and then I could be putting all my equation down below. So I could have a whole page of these things here showing you, how varying, say, the a value affects the graph. And that's the sort of information there I might put in an appendice. Okay, so you relate the graphs and you can talk about that in general. Got the idea? So there's an opportunity for you to look like you're doing a lot of work without actually having to do a lot of work. Alright, so the other thing that you want to do here, if you want to be able to move these things around, if you make that tight, then you can move that wherever you like. Okay, so you can have your text box down there. So you can have a series of graphs showing the effects of changing the a value. Okay, which will allow you then to discuss that in a bit of detail, which will be useful. Alright, so part A, remember part A is looking at the concept of what's happening to our a value, okay, which is our max, our b value, which is our min, and our g value, which is maybe our inflection point. So you need to talk about that in general, and I've already talked in class about how you might extend that to looking at things like maybe what is the inflection point? Is that the midpoint? Possibly. Okay. What do we know about the slope of the tangent and these things here? All right. So you need to talk about the general overall understanding about, obviously, how do we know it's going to be a max? So, well, we know the sign diagram goes from a negative to a positive. So from a positive to a negative. All right. We know that goes from a negative to a positive for a min. All right. So obviously our inflection point is the change in concavity. So when is a function going to be negative and when it's going to be positive? What does that mean? Now, just going back to GeoGebra, interesting to know that when we have all these other values to be 0, right, we actually have an inflection point here, okay, because that's positive, isn't it? Right. Then if I make a equal to negative, we have negative. Right. So you can talk about the inflection point there for that. Remember, inflection point counts for 2 turning points, so that's what we're expecting to see in every case. Right. So this is part A. Obviously, part A is talking about the specific things relating the curves together. Then part B and C, you're trying to do the same sort of thing, but you're trying to do it with generic terms. All right. So rather than specific values, specific examples, you're looking at the generic term. All right. Good luck with that, and I'll talk to you in class.